So we're working on 220A today, which deals with inverses. So if you have two functions and you want to know if they're inverses, what do? So you could take one function and invert it and see if it matches the other one, or you can compose the two. So if I had 3x, so y equals 3x plus 4 over 5, and my other equation is y equals 5x minus 4 over 3. How do I tell if they're inverses? Well, I could invert this. So I could say x equals 3y plus 4 over 5, and then solve for y. So multiply by 5, subtract 4, divide 3, which happens to be this. But the way the book wants you to do it is to compose them. So let's call this f of x. Let's call this g of x. So we could either do, this says, by showing f, sorry, you can't see that. So it wants you to verify this by showing that f composed with f inverse equals the identity function x, and f inverse composed with f equals x. I don't care which one you do. You only need to do one of those. There's no sense in doing them both. So you'll plug one into the other and verify that you get the identity. So I'm going to plug this in here. 3 times 5x minus 4 over 3 plus 4 over 5. Well, the 3 cancels the 3. And then we have 5x minus 4 plus 4, so those cancel. And then 5x over 5, we end up with x. Okay, you don't have to do both. But once you're done, you need to graph them and verify that they are in fact inverses. So if you graph this function, so that would be the square root of x, its inverse is going to be the right half of x squared. So you might, on your calculator in y1, put y equals x, so you can see that 45-degree line. Then you'll graph the first one, then you'll graph the second one, and you don't need to label any of your axes, but some of these reflections are kind of hard to see. For instance, if you had this, inverting it is a little bit tough, but you just need to remember that any time the original graph hits that reflection line, those points are going to be in the same place. So if you kind of look at that angle there, we're going to mirror it over here. And this goes away from the line and then toward the line, so like this, and then like this, something like that. So you'll graph each one of those, which is easy to do. But in the next set, you have the graph. You need to create the inverse yourself. So we're doing 19 to 27, and then graph the inverse of the one-to-one function that is given. So if you look at number 30, well, let's do 34. You need to draw that reflection line. So the inverse for that is going to look like this, like that, and like that. Oops. Something like that. Pretty simple, right? Okay. Get to work.